Hello dear students, welcome back again in this channel of chemistry, the study of particularly engineering chemistry. The name of channel is Chemistry in Engineering and this is Dr. Jyoti Shegokar. So today our topic of discussion is octane number and cetane number. Directly we will study octane and cetane number and then we will see how it is related to knocking tendency in the diesel engine as well as in the particularly the gasoline engine. Guys, one thing that is to be said here, the octane number is related to the gasoline engine, that is petrol engine, while the cetane number is related to the diesel engine. Okay, so here one of when the processes of all the improvement or the developments are there in the engines or the vehicles was going on. So during the days of 1872, in 1872 a scientist named Edgar had seen there that all the fuels which are there used in the gasoline engine and the diesel engine were different. So which is that fuel which is required to minimize the maximum knocking tendency, means which is having a nearly no knocking tendency is there, it's seen at that time. So he has got one, particularly in case of a gasoline engine, one of the substance which is showing a very low knocking rate. So he had seen that particular substance, or the example of that, it is nothing but the 2,2,4 trimethyl pentane. So 2,2,4 trimethyl pentane, which is also called as an iso-octane. So iso-octane was that substance which was having a very low knocking tendency in gasoline engine. Then from that, as the chemical structure which we have seen just in the very recent lecture, you can see it if you want. So the knocking tendency in that case is particularly related to the particular type of compounds, like the straight chain hydrocarbons are showing a very high knocking tendency. So in that case, whenever the compact structures are there, they are more favorable for the gasoline or petrol engine. It had been seen by this Edgar, and then he chose that particular type of a substance which is showing its very minimum knocking tendency. So he has made an arbitrary scale. On that scale, the octane number, that is octane, as it is a iso-octane, octane number had been decided at that time. So it is 100. So octane number of when our fuel in case of a gasoline engine or petrol engine is a octane. When it is an iso-octane, it is considered that it is having 100, its octane number, which is nothing but the octane rating also, means it will not having any type of the knocking tendency. Means when the knocking tendency is to be minimized for proper increasing the efficiency of engine, it must require some of the fuel which is required there. So he had seen that octane is showing a very good and smooth working of that engine was at that time during the use of this particular iso-octane is there. Then at the same time, he has seen one fuel which is called as a this heptane, n-heptane, which is having a straight chain structure. N-heptane 7-membered carbon. So it is as it is a straight chain, we know that in case of we have seen in case of that knocking, that when a straight chain structures are there, they are showing a very high knocking tendency. So he has compared these both and it is found that this octane number of this particular heptane is 0. So it is considered that whenever the mixture or whatever the mixture is there in the fuel, it will be considered in terms of the octane rating. So any type of fuel which is present or any mixture which is present, it is firstly tested as a rating. So when it is tested, it will have some of the octane number. So that octane number of that fuel, if it is 100, so it is said that it is having no knocking tendency, it will not show any knocking tendency. So from that, the rule has been made that the It must have some octane number to show more anti-knock, particularly in case of a gasoline engine. So when just consider that one of the any example of the fuel, if it is having its octane number 60, any fuel, so it is considered that it is having 60% octane, that is particularly iso-octane, and 40% n-heptane, then whatever may be the composition is, so it is called as an octane number of that fuel. So it can be defined systematically as the percentage or the proportion of this iso-octane in the mixture of iso-octane and n-heptane. It is the proportion of particularly iso-octane in the mixture of iso-octane and n-heptane. It's called as octane number of that particular fuel. It will be, or it will not be very high generally in the fuels which are used. So particularly if it is up to 70, octane number is 70, then it is said that the fuel is at a good quality, or that fuel is having a high octane number, that is 70. It means that it might have the iso-octane 70 and n-heptane 30%. So this is called as an octane number. It is a percent by weight, or sorry, percent by volume we will say, because it is a liquid. So percent by volume of the iso-octane in the mixture of iso-octane and n-heptane is called as an octane number. Higher the octane number, good will be the quality of gasoline or petrol. So there will be the very low knocking tendency in the gasoline or diesel engine. Okay. Now in the same way, but in the contrast, I am saying these both words, that in case of it is because in case of a diesel engine, in diesel engine there are number of differences than gasoline engine. Like in gasoline engine, it will be, the ignition will be started by spark, but in case of this diesel engine, ignition will be started by the compression ratio. Generally in this diesel engine, the very high pressure is there, up to 40 kg per square centimeter. Due to that high pressure, temperature will increases up to 500 to 600 degrees Celsius, and when the oil as a fuel will be inserted inside, it will firstly it will be converted into vapors, and then it starts to burn, and when it starts to burn, again the pressure will be increased. So from the 40 kg per square centimeter, pressure will be increased up to 70 kg per square centimeter, and when once the pressure is increases and total insertion of oil completes, so the pressure will start to decrease. But as the total oil will be inserted inside the internal combustion engine, that particular cylinder, it starts to burn, and when it starts to burn instantaneously, there will be a knock which is called as a diesel knock, which is somewhat different from the gasoline type of engine. In case of gasoline type of engine, knock will be started with some unburnt portion of the carbon or unburnt any fuel which is present in the cylinder. But in this case particularly, by increasing the pressure due to the change in compression ratio, higher the compression ratio, it will be good for the properly processing in the engine. I have already said this thing. But when the ratio is not proper, when the directly the spontaneous ignition will be there, due to change in ratio, there will start ignition in case of this internal combustion engine of the diesel. It is already now studied. Okay, so in case of a cetane number, again the it is also studied by this Edgar, and it is shown that in this case of the diesel engine, a particular substance which is called as n-Cetane. Cetane is a 16 membered alkane which is having the 16 membered carbon present in the alkane. So it is a straight chain, particularly alkane. You can see here I have drawn already the structure of n-Cetane. It is having 16 numbers of the carbon. So it is having its structure C16H34. n-Cetane is there. So it is a totally straight chain hydrocarbon. When the Edgar saw that it is having a total straight chain, and when it is applied in the diesel engine, it has shown that a very smooth working and totally no knocking tendency found in the diesel engine. So he has shown that this particular cetane is having 100% number of this quality of the process in internal combustion engine of the diesel. So it is said that the fuel which is having cetane number 100 is a very good quality fuel for minimizing the knocking tendency. So in the same way, for the definition, the percent by volume of n-Cetane in the mixture of n-Cetane and alpha-methyl naphthalene. Alpha-methyl naphthalene is a substance which is considered here for the comparison, that this alpha-methyl naphthalene is having its cetane number 0. Means whenever there is a 100% alpha-methyl naphthalene, there will be 100% knocking tendency in the fuel. So it is considered that whatever may be the fuel present, whatever may be the composition, it will be considered as a cetane rating particularly. So when the cetane number of the fuel or the diesel, it is 70 or 80 something, it is having the 80% of the n-Cetane, while remaining 20% of this particular alpha-methyl naphthalene. As it is a naphthalene, it will show the very high knocking tendency in case of a diesel engine. See here, in case of particularly diesel engine, whatever the aromatic hydrocarbons or naphthalenes, they are showing the very low knocking tendency. Is it? So that's why in case of a cetane, they will show a very high knocking tendency, and the stretch and hydrocarbons will show a very low knocking tendency. That's why these will be more superior on this. So in this way, there occurs the process of study of particularly the cetane number. So in this way, guys, we have studied both cetane number and octane number. This is related to the quality of the fuel which is present in the diesel engine, while this is related for the quality of the fuel which is in the petrol or the gasoline type of engine. So guys, both these points are very important according to exam point of view, and these are very nearly the last topic of this particular unit. So guys, you study it well, watch this video once again if it is not understood at once, and like the video, share it to your friends who are requiring such type of videos, and also subscribe the channel if you have not subscribed it already, and also hit the bell button for the such type of videos. So guys, thank you for staying with me. Thank you for watching the total video. Thank you once again.